think we can start. Thank you everyone for coming to the presentation. My name is Ball-llovera, and please share yourself with Candice if you want. I'm going to be talking about clean architecture and domain-driven design for enterprise.NET applications. This is a topic that is very close to my heart. I've been using different kind of architecture, and during my experience with different architecture, this is what I'm using in my latest projects. This session is going to be really packed of content, so I'm going to try to go a little bit fast to try to cover as much content. I would appreciate if you guys can hold your questions to the end. I'm going to have a Q&A time at the end of the session because it's a lot of content that I'm going to try to cover. The first thing that I wanted to say is thank you for our sponsors. They make possible to do this kind of conference. I'm also part of the organization committee of this conference, so thank you for your support. This is the agenda that we are going to be covering. First, introduction and primary goals of this presentation. Then I'm going to briefly cover clean architecture, what it is, domain-driven design, solid principles, design patterns, and then I'm going to deep dive and give some demo. And in the demo, I'm going to balance between some PowerPoint slides and some real Visual Studio code. And there's going to be the application running as well. Let me show you first the application that I selected to showcase this architecture. The application is the one that was presented in the keynote. So let me move this screen to my other, with my glasses on. Okay, so this is the web application that you guys, when you scan the QR code, you guys see and you have the possibility to enter a feedback for the whole conference, or you can see all the speakers for this conference, everything with pagination. If you would like to see any specific speaker details, you can see it, which is the session that he's speaking about. You can also give feedback on the session itself. And the other thing that is on the application is if you would like to have to favorite some sessions, you can make that in your agenda, and that will be easier for you to select the session. So this is the end result of the architecture. What we're going to be talking about is not about this application, it's how this application was built. Okay. One thing that I wanted to mention is one of the goals of this whole architecture is with the minimum effort from the development point of view with a single source code, trying to reach the maximum reach from all the kind of users that exist in the world. For example, most of us use web applications, and this is the web application that is developed, this one over here. If you see, this is the web application is the same one that you guys scan with the QR code. But at the same time, this application allows to, this architecture allows to have a native Android and native iPhone application. So it's running natively on your devices. Unfortunately, there was no time for this conference because Google forced, when you deploy an application to the store, to the Play Store, Google forced that the application needs to have 14 testers, and after having 14 testers, you need to 12 testers, and after having 12 testers, you need to wait 14 days in order for your application to be approved to be in the Google Play Store. So there was no time to have this application in your mobile device as a native application, but it's exactly the same look and feel the web UI. Let me go now with the meat of this architecture. The introduction is that the need to build robust, maintainable, and scalable software system has inspired the development of numerous architecture patterns and methodologies. Among these, clean architecture and domain-driven design have emerged as leading paradigms, both emphasizing the creation of high-quality software that remains closely aligned with evolving business needs. One thing that I would like to mention is we have a lot of AI nowadays. It's very easy to create an application. So with AI and doing vibe coding, anyone can create an application, especially if it's a small application. But when you are in an enterprise setup, you need to architect your application in a way where the maintenance of the application will be easier for big teams, not for only one or two people. So this talk is more oriented to that, to enterprise architecture, multiple teams, complex applications. Which were the primary goals that I did? So the first one is create an architecture that provides a powerful foundation for building robust, scalable, maintainable, and secure enterprise applications by combining clean architecture and domain-driven design. And I'm going to go a little bit in detail about this. Integrate solid principles, proven design patterns, and best practice in modern software engineering. Promote code reuse and reduce duplication, enabling faster development and easier updates. Ensure the architecture supports maximum runtime performance. Reduce manual effort and increase development velocity. Support different database platforms. For example, if your application would like to have the database in SQL Server or Cosmos DB. And maximize user reach by enabling cross-platform UIs, web, mobile, desktop. Clean architecture. This was by Uncle Bob, also known as Robert Martin. It was introduced to aim to create a structure where the business logic is independent of frameworks, user interface, databases, and external agencies. The core principle of clean architecture includes independence, which means the business logic core should not depend on any external system or framework. Testability, the system should be easy to test in isolation. Flexibility, changes in external systems should not affect the core business logic. And maintainability, the system should be easy to maintain and evolve over time. This is the solution explorer of the .NET application that you can also see it here. Let me move this to the other screen. So this is what clean architecture proposes. A domain project where all your entities are, an application project where your use cases or business rules are, independent of if you are using SQL Server or Cosmos DB. So that way you can do real unit testing without having to mock the different dependencies. Infrastructure, that's where your data access layer will be, persistence, and other external services like email services. Web API is the front end for the middle tier for providing all the web API access. And then the presentation layer, which I'm doing it in, I'm going to be explaining that in a little bit. This is the diagram that is better illustrates what I just spoke about. Domain is the center of everything. That's what clean architecture or onion architecture or hexagonal architecture. Different names at the end is basically the same concept. application, web API, and infrastructure. And the external brown color is the UI layer. Usually, when you guys search for clean architecture and sample of clean architecture over the web, most of the samples stop at the blue circle. So they call the presentation layer the web API, which is the interface to the outside world for your application. But I wanted to include the reality is that your web API is not the final application. Final application is the UI. You need a UI to show to your users. So I included in my architecture, following the same clean architecture principle, the UI. And if you see here, down here, this is a shared UI which using MAUI and using Blazor, they combine the same exact code. You don't need to duplicate it. And you can have a Blazor web UI for the web UI and a MAUI UI. Additionally, if you don't like to have MAUI UI or Blazor, you can have Angular, but then you will only use the benefit of the blue, green, and orange circle, not the orange circle, not the brown circle. Let me continue here. Don't worry, I'm not gonna read all this. This is like a high level to, my intention here is to allow you to see what's possible, how you guys can think out of the box and try to implement that by yourself. At the end, I have my contact information if you would like to contact me for any question. Domain-driven design, that was pioneered by Eric Evans and focused on aligning software design closely with business domains. And the key concept of DDD includes the domain, which is the sphere of knowledge and activity around which the business is centered. Entities, which are the objects that have a distinct identity within the domain. For example, entities in the application that I show you guys is a room is an entity, a session is an entity, a speaker is an entity. Value object is object that describes certain aspects of the domain without needing a distinct identity. For example, money. Money is a value object because you can have $5, but you need the number 5 and the dollar to know that it's in US dollar. It could be 5 in another country, it could be 5 pesos. So that's a value object. Aggregate is cluster of entities and value objects that are treated as a single unit. I'm not gonna go too much into details, it's a huge topic. Repositories and services. Basically, the diagram that you see on the right is what Eric Evans proposes when you are following the right way of designing an application from a domain-driven design perspective. And I try to apply probably 90% of this into my architecture, the one that I'm presenting today. Solid principles. There are 5 main solid principles, which is SOLID. First one, single responsibility principle, that each project, each class, or anything that you have service repository, anything should focus on a single aspect of your application. Don't try to mix a bunch of different things into a single class. That's not maintainable. The open-close principle, it says that abstractions allow new implementation without modifying existing code. List substitution principle is about implementation of interfaces that can be substituted wherever those interfaces are used, ensure correct behavior. And classes like, and I'm putting an example here of a real class that I use generics and constraints to ensure derived types that can be used interchangeable. Interface segregation principle is that the interfaces are focused on a specific, so consumers only depend on what they need. Don't try to provide more than what you really need. The application layer defines contrast while infrastructure provides implementation, keeping interfaces lean and purpose-driven. And the last one, dependency inversion principle. All dependencies are injected, allowed for easy substitution, testing, and decoupling. The next slide is just a sample. I'm not going to go through this slide. It's just a sample of some of the design patterns that I'm using in the architecture. There are in total 23 design patterns from the Canon 4. I'm not going to go through this because we need time to cover more. The code map for the solution. You can see it live here. So this is the code map for the solution where you see each project from which other project depends on. And the important thing here is whenever you're using a clean architecture, you should know where you should be putting your code in. Don't try to put something that is supposed to go into the application layer. Don't try to put it on the infrastructure layer, because then you are not following the clean architecture, and you will have problem maintaining your code in the future. Okay, so what is left of this presentation is basically I'm going to explain a little bit about each of the layers. I'm going to go really quick about what is left of this presentation so you guys have an idea of what the next 20 minutes are going to be about. It's like domain project, mapping project, application project, infrastructure project, web API project, UHL project, so, and UI project. So on each slide I'm going to try to spend only 2 minutes. I'm not going to read everything that is on each of those slides. But then on each project I'm going to try to provide a real example from Visual Studio. So that way it's not only presentation, it's also real stuff. And at the end, I'm going to close with the real business value, what benefit you can get from this presentation, and any follow-up question. Domain project. This serves as the core domain layer of the solution. The following principle of the domain-driven design, organized by bounded context and clean architecture. Its primary purpose is to define the entities that are central to the application in problem space, independent of infrastructure or UI concept or UI concern. This is where we have domain entities, value objects, domain events and aggregates, specifications and business rules, attributes for code generation and validation classes. Just an example of those. Let me show this here. I'm gonna switch to Visual Studio. Here. And in the domain layer, I have, for example, the speaker. I'm gonna show only one. So this is the speaker entity, and it's using the field record class. So it's using the record from modular C#, and it's using different things. One thing that I wanted to provide here is that usually entities are not the ones that should be transferred between layers. It should be DDOs. And usually on an enterprise application, you have an entity folder with a bunch of entities, probably one by one of your tables. And in an enterprise application, you might have a database with hundreds of tables, so you might have hundreds of entities. But then for each of the entities, you will need to have the corresponding DDO. And that's error prone, because what if you forget in the DDO that you include last name in the entity and you forgot that on the DDO? So I'm doing that in somehow a source code generator that I implemented. The source code for that source code generation is here in utilities, so you can adapt it. And so that way you only need to define each attribute once, and your DTO automatically will get that. That way it's less error prone and you need to work less in general. And on the DTOs, if you want to represent an event speaker in your DTO, you can say what data type you want, so you can even configure that source code generator. Then the other thing that I wanted to mention, the last thing I wanted to mention here on the common on the domain is common auditable-based entity. So that one, this is the entity that represents on the database. For example, this is the database for all the users that have scanned the QR code of the conference. And this is the database for the conference. And you see here that so far 94 of you guys have been using this application today. But the interesting thing that I wanted to show here is that in this architecture, every single top table has this deleted, created on, created by. So for auditing purposes, when an audit is coming to your company and someone asks who created this record or who deleted the record, so everything is automatically stored. It's deleted, it's a soft delete, so you don't need to, when you delete something, it's not really deleting the record, it's just marking it deleted as one. And what allows you to do that is this auditable base quantity base entity generic that every single entity inherits from that. I'm not going to continue with the domain project, and this is the domain project which I spent the most time. Let me see how I'm doing on time. I need to speed up a little bit. Mapping project. Mapping project is the next layer where you need to say, okay, how an entity will get translated to a DTO, or how a DTO will get translated to an entity. Usually in .NET application there is a very common approach, which is AutoMapper. It's a NuGet library, AutoMapper. The disadvantage with AutoMapper is that it's very flexible, but in my experience, it adds a lot of runtime time. So your whole application will get slower if you use AutoMapper. The solution that I'm proposing is to use a design time replacement of AutoMapper, and a good replacement for that is, let me show you here. A good replacement for that is, I'm gonna do the mapping. This Mapperly. So Mapperly is a NuGet package that will allow you to have from just defining, for example here, you define, okay, I want that let me go to speaker mapper. So you say, okay, I want to map my DTO from using map to entity. So that's all you need to do. And here is where you define how you map your entity from. But all this, the most important thing is that all this happens at design time and compile time. You don't lose valuable time when you execute in trying to map from entities to DTO. Speaking of performance, we all want our application to run as fast as possible. So let me show you another library that I'm using. Where is my mouse? Okay, I got it. So another library I'm using is this one over here. This library allows you to, if I'm going to the UI and I'm doing a new thing, sessions. So this went to the web API and did a bunch of calls. So what if those calls are slow? So here you can see, oh, let me see, my speakers get all. That means that on each of the layers of the application, you will know it took 27 milliseconds on this method on this layer. It took 225 milliseconds on this other method on this layer. And you can even see on the SQL server, in this case, what is the query that was sent and how long did it take. So if your application gets slower, you can focus your effort in what is slower to try to optimize it.
And what do you use to do that? What do you use to do that? You said you used another new
That's a library that is called here. I have all the packages here. Micro.
So mini profiler?
There is something here. Hold on. Let me answer your question at the end.
Okay.
But trying to remember the name. Mini profiler. So, and the way that I'm doing mini profiler is using another pattern, which is the decorator pattern. That's one of the 23 design patterns. One of them is decorator pattern. So that way you don't need to change every single class in your application in case you have 100 tables and 100 entities. You just need to do it once, a decorator pattern, and in the decorator pattern you say, I want you to also log every single call to every single method. So with only one line, you can incorporate that in your whole application. But the name is mini profiler. Okay. Continuing with the next layer, application project. Each layer is important. I don't even know which is the most important layer. It depends on what you think, but domain layer is very important, but application layer is also important. Application layer is where you put all your business rules, or use cases in clean architecture language. So in there is where you put how my get all will be programmed, how my exist, if you have any specific business rules, that's where you put the business rules. I'm gonna show just an example. I think I'm right at the middle of my time. So the example I'm gonna show is entity service space. So let me go here to Visual Studio. Application, entity service space. So this is a base class that is generic, where all your 100 plus entities will inherit in your application project, and you don't need to repeat that 100 times, only one time. And here, I'm trying to support, when I said independent of databases, this is what I meant. Let's say that you have SQL Server today, but SQL Server is costing too much to your company, and you'd rather have your persistent layer instead of SQL Server. You'd rather want to move it to Cosmos DB, which is a NoSQL database. Entity Framework has an interface with Cosmos DB, so I'm using Entity Framework. But in order to support all this and not having to change your application, I'm doing what I call navigation. So in a parent-child relationship, in the parent-child relationship, if you are completely independent of Entity Framework do that completely for you. But if you want your parent table in SQL Server and your child table in Cosmos DB, you need a way to do that that relationship. And I'm doing it here in an optimal way. I even say, okay, if that if that is natively supported by Entity Framework, then I defer to Entity Framework. I don't do anything in addition. And that's what I have here in navigation. Will include. Thank you. So this is a decorator pattern, but if you go again to the real one, go to definition. This is where I say navigation properties supported include and unsupported include. What I call supported include is the ones that if you are completely inside a SQL Server database or your parent child receipt is inside Entity Framework completely, and I don't get in the middle. But if it's between Cosmos and SQL Server, then I get in the middle and I support that. Another thing I wanted to mention is the filtering page number. So everything here is tried to be optimized as possible. When you come here on your application and you say I only want 10 sessions, this is pagination, only 10 records. So those 10 records are the only ones that are fetched from the database, and the database only query 10 records, so it's as fast as it could be. If you change, and you say, I want 100, then I'm gonna go to get 100. And all that is supported natively by this framework, and is here in the pagination. So this is where you get you can even do filters here in the application. You can say, give me all the titles for the conference, for this conference that contains building. So this is filter applied. But everything, including ordering, is also supported. I'm gonna move to the next layer, infrastructure. And probably a more interesting part is where I'm about to go. Probably this is very theory and it's more for enterprise, but I'm about to go to the UI part. It's a little bit more fun. So bear with me for 3 more minutes on infrastructure, and then a more interesting part is gonna come. Infrastructure project is where you have your persistent layer, where you have where entity framework is being used. The advantage of using clean architecture is that you can do all your unit testing directly on the application layer, and you don't need to even mock any database, because it's just the interface is only the one that is injected into the application project. With infrastructure, I'm not going to spend too much time here. Only I'm going to show a few interesting points just to show you what is possible that you could do. One of the things is infrastructure. One of the things is whenever you have this framework, you can define which database you're going to support. In this case, I'm supporting Cosmos DB, SQLite, and SQL Server. But it's very easy to add support for a new one. As long as you create your, so this is how each of the databases are supported. For Cosmos, you say, okay, each entity is a container in Cosmos. And the primary key is not auto-generated, because Cosmos doesn't have primary keys. I mean, it has, but it's in another. It's not like an identity like in SQL Server. But for SQL Server, each entity is a table, and it has an auto generator. So that way you can abstract to a database abstraction layer, and the way that you could, let's say that I would like to the speaker. Let's say that I would like the speaker entity instead of in SQL Server. Let's say that I want it in Cosmos. All I need to do is here to put, instead of SQL Server, Cosmos, recompile the application, and everything will work. In this case, this architecture is gonna look for Cosmos for a speaker in the Cosmos database, not in SQL Server. And all the party chat relationship, even if it's across different database platforms, it's gonna still work. Another thing I'm using here is unit of work. It's another of the design patterns that is where you can have all your entities as a whole, and you can apply the repository pattern there, and you can apply the transaction as a whole and roll back the transaction completely. Then, last layer between the UI is the Web API layer. Web API layer is much simpler. It's just the API layer to the outside. In this case, it contains controllers, like MVC controllers. And the important thing is that everything is from a base class. So you don't need, when you have a new entity, one of those 100 entities, let's say, in your table, in your database, all you need to do is, let's say that you have a speaker controller. All you need to do is to inherit from this, and that's it. You don't need to program anything else. Everything is on the base class. Web API layer has different things that support the Swagger, health check, dependency injection, database initialization and seeding. I don't have time to go into all that. Just a sample of some of them here. Let me go to here. This is the health check. This is if in your CI/CD pipeline you want to know if the web API is up and running, then this is the health. You see that your web API is healthy and the database is also healthy. SQL Server. You can also have the Swagger to know So you can even either have it here or in a Cosmos collection to hit your endpoints. So this way you can hit all your endpoints for get, post, put, delete. As I said, delete is a soft delete in this case. I believe that's the most important thing on the web API. I'm gonna move to the UI part, which is probably more interesting. On the UI part, since .NET 6, Microsoft started with Blazor, Blazor Server, Blazor WebAssembly, and then independently they have Xamarin. And it's like 3 different ways of providing UI for the user. The problem with that is that you need to do the same thing 3 times. For the web, Blazor web, one programming. For the WebAssembly, if you want reactivity, like equivalent to Angular or React, then you need to program that separately. It's not reusable, the code. And in MAUI, in Xamarin, the same thing. Even though Xamarin allows you to have multi-platform to Android, iPhone, but it's not crossing over the web world. Microsoft then was upgrading, improving .NET 7, .NET 8, .NET 9. .NET 10 is about to be released in 1 month. And starting with .NET 8, Microsoft came up with this idea of why don't we provide a way of just a single way of doing your in one place the code, and you can hit the Blazor web server, Blazor WebAssembly for reactivity running directly in the browser, and MAUI. And this is what I'm about to show you. Basically, all the UI that you see here for the application, all this, let's say that you want to provide a feedback for the conference, this is an option. So all this that you see here, you can also do it from a MAUI application. And that MAUI application, let me run it here. That MAUI application is this one over here. Everything is adapt itself. Session. So you see that it's the same look and feel for web and for MAUI. Even for when you install in Android, this is the application, the native application in MAUI, in your Android phone. So from the Google Play Store, all is the same look and feel. How that can be possible? You only need to create here file, new. Let me create a new Visual Studio. This is like you are doing it from scratch. File, new, and then on the templates you do create a new project, and you say here MAUI. You see here the .NET MAUI app. This will allow you to hit Android, iPhone, Mac, but it won't allow you to hit web. What you will need to do is this one, .NET MAUI Blazor Hybrid and Web App. This is the one that will allow you to hit everything. And this one is what I'm using here in interfaces. By doing that file new project, it will create a shared Razor library, and this is how you do your unique UI. For example, for a speaker, this is the speaker list. That what you see here in a speaker list when you come here to speakers, this list of speakers that you see here, this is the I'm using the mod Blazor library, and this is all you need to do. Which columns you want, and since this is in a shared UI project, it will be consumed by your MAUI app, allowing you to hit Android, iPhone, Mac, Samsung, everything else. It can be consumed from your web. This is the Blazor web, and it can be consumed also from your Blazor WebAssembly to provide the reactivity. When you do a MAUI application, there are 2 main ways of doing it. One is doing it the Blazor way, and the other one is doing it what's the name for the other way? The summer way. So he did a presentation earlier for MAUI doing the summer, which is another way of doing MAUI applications. Both are very powerful, but if you want to hit also web, you will need to do the MAUI in the Blazor way, not in the summer way. I'm almost finishing, and I'm gonna do the final slides before opening for questions. Okay. Then this is what I was talking about the three different UI projects for Blazor Server, Blazor WebAssembly, and MAUI. This is the last slide before the question and answer. What is the benefit that you can get out of this? First thing is, you saw what is possible. You can adapt your own applications. You can start from scratch a new application, or you can incorporate some of the ideas that you saw here in your existing applications. The main thing is that it's important that you do this architecture allow you to have in the same solution. It enables rapid development and future-proofing with Microsoft Native Framework. It's a modular and maintainable solution with clear separation of concern. How many times we are in enterprises, we are the developers, and we need to inherit an application from another developer. We need to maintain a code that is poorly written. And to add a new feature is very difficult because you need to follow probably the bad practices that are already there. So it's better to have a good, robust architecture, so that way new developers, when they come on board, they will know, oh, this is the way to do it, let me try to follow this, and they will start realizing that the velocity to develop new features is going to be faster than starting to staying in the previous architecture. One thing that I didn't show is the security, identity, and access management. So this architecture also supports OpenAI and OAuth2 for authentication and authorization. I already spoke about Blazor and MAUI, the web API front end, the login. I also have login incorporated here. Every single action in the system gets logged, and you can, in addition to the audit fields on every single table that created on and modified on, you also have login. And the most important thing for all of this is the last point number 7. Again, this is more for bigger applications, enterprise, in an enterprise environment. Accelerate time to market. With code generation, DTOs, and shared components, you can reduce manual work and speed up feature delivery. This is the end of the presentation. Hopefully it was fast, but I wanted to give you a high-level overview of what's possible and what you could do in your own applications. I'm opening for questions. Any question that anyone has?
How much of the application code is generated from the framework that you built?
Sorry?
How much of it is generated from the framework you built?
Let's say that you want to apply this architecture to a new application that you want to. I would say that 60% is common code that you don't need to worry about. It's already baking. The other 40%, and in that 60%, I'm including the auto-generated code for the DTOs. I'm including that. So the other 40%, which are your real entities, at least in this example, I'm providing you samples like a speaker entity, session entity. So if you have a specific entity like a bond entity, then you need to only adapt where it says a speaker, let me put bond, and try to follow the same. So it will be faster even if I'm talking here about a speaker session, because that's what this application is about. But if it's about another word, you can easily adapt. But it's like 60% or 40%. Your question?
Yeah. In the what is that? In the infrastructure layer, when you showed the example with the speaker configuration file, when you're specifying the properties and I guess the constraints of those, I'm not really sure of the term.
Yes.
Do you specify those as a best practice to specify those in like a config file, or can you do it in the I guess the code behind in the actual like logic?
Good question. I see that you are very inside into this. Thank you very much. So to answer your question, in the infrastructure layer, here, you can, there are two answers to your question. One is the configuration for your entity. Let's say you have the speaker entity here. In here, you specify, I said earlier, if you want to move that entity from SQL Server to Cosmos, all you need to do is to replace SQL Server to Cosmos here. That's all you need to do. But here, I'm also saying, and this is a way of the entity framework way, which is through doing entity type configuration. So that's something existing in entity framework, and this is how I define. Here I'm saying, okay, I have a first name column that this is something that I created to abbreviate, but basically it's something like this. I have a bio column that has a MAC length of 8,000, and it's not Unicode, and it's not a required field. So that way, when you run the application, that's another thing that I forgot to mention. I made this architecture in a way that you don't need to create your database at all. You just create your entities, run the application, and the application in the first run is going to create the database for you. But that's how it's reflected here. So if you come here in columns, or the design of this, probably I lost connection to, but it's reflecting that in the database, like 8,000, varchar 8,000. This is just an abbreviation to say that it has a max length of the name max length, which is 50, and that is not Unicode and it's required. It's just an abbreviation to provide consistent behavior for all the names in the application. Yeah. Did I answer your question?
Yeah.
Any other question? There are candidates here. Please help yourself. I don't want to come with all this to my house because I have a 4-year-old daughter and I don't want her to eat all this. And this is her mom. So thank you very much for attending the session, and my contact information in case you want to contact me is this one. So that's my email. Thank you very much.